All right, welcome back. We are COMP301. That is Linux operating systems in the summer 2020 semester, such that it is. And it is week 1, part 2 of our broadcast. We're talking about an intro to Linux today. And I also want to review some of the stuff we talked about last day. Okay, so that's what we'll be doing mostly today. Before we begin, are there any questions from anybody based on the stuff that we talked about last time? I gave you a bit of homework to do also that we have to talk about. For people who weren't here, I asked you guys to update your Linux environment. One thing we talked about last day was that we will be using a virtualized Linux environment. I'm just going to bring that up right now before I start the PowerPoints. Right, so let's just get into that. So again, remember what we're doing is we're using VirtualBox. There's VirtualBox, and right now I've got my Fedora Linux server running. Of course, people are calling me when they know they shouldn't be calling. It's just the way it is. Yeah, so that's what's running right now. We've got our VirtualBox running. I got my Linux operating system. I'm just going to bring that into view in a second. So here it is. You can see that this right now is the Linux operating system that we built together last day. I'm just going to log in here. Not much to look at really right now. One thing to note is that it is scaled so that you can see this operating system. We installed a couple things last day. Google Chrome. We also installed Visual Studio Code. So those are two applications we installed through the user interface, which is typically called GNOME, but I like to call it GNOME. Actually, the right way is to call it GNOME because this is it's based on GNU, which we'll talk about today. What is GNU? It's a funny word and a funny beast, but we'll talk about it. All right, so yeah. This is what we built last day. So one thing I asked you guys to do as homework last day was to go into your applications, right? If you go to software, and if you notice on the right, there was a few updates. There's even been some updates since then. And I said, please go ahead and update your operating system. This can take a while. You can see that I only have a few updates here. If I click download now, that's going to take a while to go through. OS updates, when you see OS updates like this, which says it includes performance, stability, and security improvements, that can take a while. So I'm going to let this go because I'm not going to do a long lesson today on the operating system. I'm going to talk about, I'm going to refer to you to the video from last day. And one thing I want to do before we continue is I'm just going to go to eCentennial here. One sec. And if you look at week 1, which I'm going to get into in 1 second, then inside week 1 you'll see the video for last day. And what I'm going to do is I'm just going to capture the video from today, so that way for those of you who find it more comfortable to run the video service, like actually run it on YouTube, because you feel more comfortable with that, I'm just going to go and add in the link to the live stream right now. So you can actually watch the live stream live, and it'll be just a little bit behind, kind of what I'm talking about here. All right, so there'll be a bit of a delay, right, based on the fact that I'm streaming live. And I'm also kind of going through everything. So I'm just going to pull this live stream up so it's underneath the other video. So there's both videos up. And again, just to briefly show you what this looks like. Here's what it looks like. You can see that up on eCentennial, there's 2 videos. One from last week. There it is right here. And one from this week. This is the one I'm currently making. That's live and being broadcast on the internet. I've also got this personal demo video we're going to talk about today. But that's a spoiler for later on. Okay, so you can see that this is going to require what we talked about before. If I'm just updating, it's going to ask me to restart and update, which is perfectly fine. I'm going to do that, restart and install. And this can take quite a bit of time. Now, I asked you guys to do that last day, and I already did it, but there's more updates. Sometimes the updates have a potential of breaking your install, and that's okay. Because remember, that steps involved at putting a system together isn't that long, right? So, I mean, like you saw last day, it took us a long time, but only because we went through the whole process of how to set it up, how to set a virtual machine up, downloading the ISO, and so on, which is about 2 gigs, 1.8 gigs, something like that. And that can take a long time. Now you can see that an update doesn't happen immediately. This is probably a smaller update than the one that you would have done last day. So so this won't take long, but it's still going to take a while. I'm just going to pull this off the screen because you don't see this right now. So let this do its job while we're talking. Okay, that's happening off screen. So anyone, first question I have, I'm just going to bring up my little PowerPoint again. This first question I have is there anyone that had a lot of problems with, kind of putting together their virtual environment from last week? And the reason why I'm asking is because I'm going to be using this virtual environment the entire semester. I'm even going to get you to code in the virtual environment, which is like, for some people, we're like, wait, why can't I just code with my regular environment? Why can't I just code with Windows or something? And the answer is, well, I want you to try and do it in Linux. This is the exercise this semester, right? Do it in Linux. Make it full screen. Make it look like it feels like you're running a Linux system. And this way you'll learn about the Linux environment. And this is the idea. And I'm going to do the same thing. I'm going to try and run everything we do in a virtualized kind of environment where when I run Python in the second half of semester, then we'll be doing it there. So the first half, like I said last week, is all about how to run things with Linux. And last day, let me just talk about where we are this day. So here's where we are this day. We're still week 1. Chapter 1, 2, and 3. 1 in the book covers history of Linux, which we're going to talk about today. 2 and 3 really talk about setup and installation, which is what we did last day. So we kind of did all that. So again, looking at the chat, is there anyone from last day, for whatever reason, that had challenges with downloading, installing, and setting up your virtual machine and your ISO from Fedora? If so, one thing to do before I take questions is go ahead, take a look at that video that I posted on eCentennial. Every week I'll be posting a video or two, probably 2 videos on eCentennial, and then it'll be based on what we talk about here in class. So if I talk about let's say a setup on one day, then I'll post the video for the setup. It'll be posted immediately when we're done, and you can watch it live. Okay, so that's the great thing about this, these 2 things. Good news is I've upgraded my internet, so I can I should be able to sustain 800 megabits upload, and a good 800 megabits download. I actually was able to do that today. I did a few tests, which worked pretty nicely. So I don't think we'll have a problem with streaming content. You shouldn't have too much of a delay, although it can happen. I mean, we are going through a series of hops to get out to the internet, so it really depends on Bell Canada. I'm a Bell provider. I'm using Bell, and so on. So, I'm sorry. So, hi, are you speak now? What do you mean by that? Install Visual Studio Code on my PC and this Fedora software. Should I put that here? Should I put that here? No, you don't have to put anything here. Can you all hear me, by the way? Hopefully you guys can hear me. Yay, people are saying you can hear me. Okay. Yeah, so I'm just talking about, just again, internet connectivity. One thing I have to mention that I didn't talk about last week, okay, and I want to talk about that or last day, I should say, is that if something happens, one of the challenges that we have is during the course is because we're doing everything remotely, even though I'm broadcasting live, there's a chance that we might have a power outage, I might have an internet outage, or something like that. It could happen at any time. So it could happen right now while I'm broadcasting. And and that's the challenge, right? There's no guarantee that I can share this stuff with you at the time that's specified. It'll be the same for you. There might be a chance that you have a power outage, internet outage, whatever. Usually they don't last long. I had a brownout today as a good example. Just before this, we started producing this course, the course material for today. And I'm back. It didn't take more than 10 minutes for me to come online. However, sometimes it might go right through our recording. It might stop us. But the show must go on. And what I mean by that is, and this is kind of the new normal, if I need to produce something and I need to record something asynchronously, which means record it and put it up on YouTube, again, I will notify everybody if something happens where you can see the recording of what I've talked about, whether it's now or later. Okay. Typically, what I'd like to do is do it all in one. So you'll see me, again, we meet twice a week, once on Tuesdays between 4:30 and 6:30, and another time on Thursdays between 2:30 and 4:30. And I'd like to adhere to those times in terms of me broadcasting and do everything we have to do. Okay. So any, was it Monday? Monday, I'll be okay. Monday. Yes, it is Monday. Thank you. Monday between 4:30 and 6:30. See, my brain is Tuesdays and Thursdays. Yes, it's Mondays between. Thank you for that. Okay. Any other questions or anything like that before we begin? Okay, so again, we'll talk about it more later on, but I'm going to wait around if there's any kind of issues from a software installation perspective. I can try and help out with some of that. If you haven't followed the video though, I'd ask that you go ahead and go online later on, not now obviously because we're live, but go online later if you haven't had a chance to watch day one's video. Go there, watch it. Fast forward if you need to, but make sure you install VirtualBox, and you need to have installed at least, at the very minimum, Fedora Linux. It's got to be installed on inside your VM. I don't recommend at this point, if you're running a Windows system, that you install Linux on the metal, and that means like physically on the system by like wiping out your machine or something crazy. Don't do that. However, there's nothing wrong with having a dual boot, and that means that if you wanted to install Linux on another external hard drive or a second hard drive on your system or another partition, what you could do is if you're savvy enough, if you understand hardware, you could boot into or start Linux from another hard drive, and that's a different scenario than the one I'm offering here. The one I'm offering here is going to be a containerized version of what we're doing inside of a VM, whereas the other option would be, you're actually running on the metal. Now, there's advantages. I got to talk about this before we move on. There's advantages to running on the metal compared to if you're running in a virtualized environment. Can anyone remember? I kind of talked about this briefly last day. Anyone remember what are the advantages of running on the metal compared to running in a virtualized environment? And what can't you do? What do you think you cannot do, for example, in a virtualized environment? There's things you cannot do, by the way. How about some pros and cons? Anyone want to share those before I talk about what the pros and cons are? Someone's asking on chat. Full install is faster. Absolutely. Full install is way faster. Why? Because you're running on the metal. You're taking advantage of all the cores of your CPU, all the memory, all that kind of stuff you have access to. So yes, that is definitely cool. It's great. If you can handle that, if you can do a dual boot, and if you can run in a virtualized environment, at all, then you're okay for this semester. So what's dual boot versus if you're running, as an example, native? That's your only thing. There's no disadvantage to running a dual boot. The only thing is that when you start up, you'll have a startup screen that basically says, you can start either Windows or do you want to start Linux? And there's a way of doing that. I'm not going to go over that this semester. Full install is faster. You cannot use the host system. Is the virtual machine safer? Absolutely. The virtual machine is a virtualized environment. So if I make a mistake, if I mess up my Linux environment, it's okay. I can just recreate it. And here's another hint for you guys. You can always make a copy of your virtualized environment when it's ready to go, and worst case scenario, you can just launch that instead, right? And it'll be just exactly where you left it. It's almost like you want to take a snapshot of that and you're good to go. So it's totally fine to do that. I mean, you need the space for it. Right now, our virtual machine is only about 6 gigs, 7 gigs, because we haven't really done much with it. And if it was much larger than let's say it was 50 gigs, that might take a while. So the good thing to do, and I highly recommend this, is as soon as we're done after today, I recommend making a backup of your virtualized environment, so that way, worst case scenario, if you mess it up, by the way, it's going to happen. I'm not trying to make it be a naysayer or someone who's negative. Not going to be there. I'm telling you guys that it happens. You mess up your virtualized environment, and then when you go back and try and use it, it doesn't start, and you're like, wait, what happened? Well, because something you did. It could be in a command that you used, or VirtualBox corrupted some file or something. It can happen, right? And that's another disadvantage of using a VM, but also the advantage, because you can always recreate it or copy it. Yes, they definitely always use hackers definitely use a VM, and they also use some kind of VPN as well. So VM and VPN, and then also they're pretty much anonymous, which is pretty cool. And also their system is protected, so that way if something happens and they get hacked back, chances are there's no access to the host operating system, and you're good to go. So yeah, so that's the advantage. Here's a disadvantage of installing on the metal. I got to talk about this too. Installing in a VM is super easy. Like literally, you just go in, and just like we did last time, you put the ISO in, and then flash bang, you're ready to go, and you're running Linux, or you're running Windows, or you're running whatever operating system you want. Mac, as an example, if you're on a Mac, and sometimes a hacked version of the Mac, kind of in a Hackintosh format if you're Windows, which is not really supported by Apple. Even if you own the operating system. But so that these are all possibilities, right? You can run your virtualized environment. The disadvantage of running it on the metal is you need to install all the drivers for your VM, for your Linux operating system. So a good example is you have a graphics driver right now. I have my graphics driver, NVIDIA. You make sure that you have all the drivers and everything downloaded ahead of time that are compatible a lot of times with your environment. And one of the key drivers that you need is the network driver. If you don't have your network hardware drivers downloaded, your network interface card, your NIC, that's what we used to call it right back in the day, and it exists in every laptop and pretty much nowadays, and anything out there, then you won't have access to the internet, you won't have Wi-Fi, you won't have anything, because remember, Linux doesn't know anything about your system. It's not a plug-and-play environment. It'll try and detect stuff, but it does an okay job. Sometimes I've got it going right away with no trouble. Sometimes, it takes a while, depending on the the platform that I'm using and the hardware that I have. Because remember, everybody's hardware is different, slightly. So there might be some piece of hardware that you have on your laptop or your desktop that's not recognized by the system, and then you have to make sure you download all that ahead of time. Make sure you have all your drivers and everything else ahead of time. So that is a major disadvantage from running Linux on the metal if it's just for a course. If you're running Linux and you want to run Linux as your main operating system because that's the kind of person you are, you like to run an open source system. We're going to talk about open source and free today, which is what Linux is about. And you don't want to buy Windows, or you don't trust Windows, those Windows gods, Microsoft, they're going to, from a privacy perspective, they're looking at you all the time and all that kind of stuff. Then it's worthwhile. Then you can download everything and, make sure things are ready. You have everything ready on a USB, something that's compatible on a USB, so you don't have to access any other operating system files or anything like that. And then you can install everything in a dual boot, or another partition, or an external hard drive where you can run your operating system, and it's great. It'll be great performance. I would say 95 or 96% of all hardware modern hardware that is out there is supported by most versions, most distributions of Linux. And I say that in a very broad sense. There are some things that are just not supported, especially newer pieces of hardware. If it's a new piece of hardware, sometimes you have to wait a little longer to get the driver. Although most manufacturers nowadays will make drivers for both Windows and Linux and Mac sometimes too, depending on if it's something that you can install as an external piece of hardware for the Mac, and normally you can't, okay? Unless you have a Mac Pro or something. Anyway, so that is the kind of the state of affairs. So last day we asked you guys to update your machine, and let's just check if mine is just newly updated. Yes, it is. So that was that noise that I heard as I came in. So you can see now that after I've downloaded everything and uploaded got ready with my machine, you can see that my virtual machine is now finally up to date and running again. There it is. And you can see that if I go again to software and if I look at updates, there's not going to be any updates here, no important updates. If you see an update that's an important update here, then like I said, I'd ask you try and do your update outside of class. Don't do it inside of class. Sometimes that can take a long time, and you don't, especially if I have you doing a little quiz or I want you to do something like a bit of a lab in class, then I'd ask you to have it ready. Don't tinker with it. I'm not going to do it. I'm showing you here today. Luckily, there's nothing to do, so that's why I did it. Otherwise, typically, what I'd ask you to do is do it outside of class. Okay. What happens? Here's another question I'm going to get for sure. What happens if I have a problem? I'm asking you to do something in a quiz, and you just don't have access to this thing? That would be a problem. I mean, there's only so much I can ask, but that's why it's a good idea to have a backup of your virtual machine. So how do we do that? How do we make a backup of the virtual machine? So first of all, before you do anything with the virtual machine, copying it, whatever, you need to shut it down. So the first thing you're going to do here, and this is all before the PowerPoint we're going to talk about today, is power off, log out. Okay, first thing. And you want to do it in the most graceful way possible, which is actually going through the software and powering it down. You don't want to use VirtualBox to do this. You don't want to sit there and go like, power down my virtual machine. You want to avoid doing that as much as possible. Okay, VirtualBox is great, but remember that it's only going to do what you tell it to do. Okay, so this is my little VM. It's not big. We know where I put it. I put it on my F drive. I have a separate drive that I'm going to be using, and I'm going to show you this one. So here is my operating system files. You can see that I have something called VMs. Hey, and there's my Linux. No, look, it's up to 10 gigs. Haha. This is a great time to copy it, guys. You don't want to let it go until it's something crazy like 100 gigs, which this is slated for. My VM is working. This is a fantastic time to make a copy. So literally what I'm going to do is I'm going to copy it and paste it. So I'm going to paste it there. It's going to say copy of Fedora Linux VDI. It doesn't take long if you have a decent speed. Again, I'm using an M.2 SSD for my operating system, and this is just a regular SSD that I'm looking at here, so it's not that bad from a speed perspective. It does take a few minutes or a couple minutes to do on a regular hard drive, and you need the space. So again, I would reserve, and this is best practices for me and peace of mind for you, which is, guys, make a backup of your VM. There's nothing wrong with that. Nothing at all to make a backup of your VM. I'm going to show you how to make use of it. So you see it says Fedora Linux copy. We're just going to rename this to Fedora Linux backup. And all I did, I guess, just did in the operating system, just backed up the file. Okay? Yay! Awesome. And it's exactly the same size. All right, and let's see what happens in VirtualBox environment, right? So how do I kick it off now? Well, you'd like to think that you can go here, right? And you want to kind of add a virtual machine, right? That's one thing we could do. And you can see that it says import appliance, export appliance, virtual media manager. All right, there we go. Network operations manager. And here's what people will also try and do if you launch, again, if you go to your F drive, and if you double click on your VDI right here, then what should happen is like, hey, you're thinking that maybe, you know, it's gonna work with VirtualBox. You can pull down something that makes sense. I'm just saying, right? This is definitely something that you're going to try and do. You're going to look for VirtualBox and try and make it work, right? So wherever VirtualBox is installed, and you know, and at the same time, it might work, you know, as an example, but it may not. Okay, so you can see that even finding VirtualBox here in this long list of stuff, it's probably going to be in programs. You know, so if you notice, here's all my Windows stuff. There's my program files, and it's not there. So let's go program files x86 and see if it's there. Right? We want to definitely find where it is. And what's the other way? Does anyone remember, from a Windows perspective, what's another way to find out where VirtualBox is hiding? Because that's something we need to do. Right? Does anyone remember? Search box. Yeah, we could do that. So here's VirtualBox running, right? So again, one thing you could also do is if I right click and you know, and if I want to find VirtualBox, notice VirtualBox is right here. I can right click here, and if you go to properties on your Windows system, you can always look at where it is. So it's under Oracle, because Oracle owns VirtualBox, right? So this is what I missed, Oracle VirtualBox, right? And we can try that out too. So again, going back to that this file here, I can go open with, and I can specify where, right? So a specific other app, and I can go again, program files, Oracle. Let's see if this works. Typically, by the way, this will work, this kind of action. So tickle VirtualBox, and then you can click on the VirtualBox exe, one of these things. There's VirtualBox exe, and you can press open, and then, you know, you can pray. Okay. Oh no, look what it did. It actually opened up VirtualBox, but it's not pointing really at anything else, right? So that really isn't the way, right? I mean, you can see that that's not clearly the way. You can also try new, and you can name it whatever you want. Here's it says where is the machine folder. This is the machine folder on Tom's VMs, and I can call this VirtualBox backup. Let's try this out. VirtualBox. So this is, sorry, the Fedora backup. Fedora backup, right? And it says here's my machine folder, right? Here's my machine folder. That's fine. And it says Linux and Fedora 64. That's right next. And then it tells me the memory I have to allocate and blah, blah, blah. This is something else. This is what I showed you earlier was the disk, right? So again, we want to allocate 4096. Let's try this out. And then click next. Okay, hard disk. It says create or use an existing one. Looks like use an existing one is the way I want to go, right? And it says Fedora Linux is the one I want to use, but or Fedora. I never registered the other one. Let's see if I can find my other one. So these are attached. I want to add a medium, and I want to go into the place where I have them inside VMs. And look, there's the backup. And I click open, and it says fail to open the disk file. Details. And it says cannot register the hard disk FVMs Fedora backup blah 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 because the hard disk Fedora with UUID blah 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 already exists. So what does that mean, and how can this work? Well, the reason why it already exists is each installation of your VM has a unique identifier. That's what it is, right? And that's what this UUID is. So if I created a backup, so Fedora backup, and I tried to load it at the same time as my I have Fedora Linux installed here, then what's going to happen is it's going to say, "Man, you already have that one. What do you mean?" Right? So the right thing to do, instead of doing it this way, is when you need it, you just rename it to the same one. You can also unregister this one and re-register the other one, and you're still good to go. I'm not going to go through that process right now, but that's the way you would do it. Okay, so that is a way of doing it, and definitely you're going to start the correct one. Okay, because that's the one that's been loaded. But I definitely highly recommend. I know you don't think it's important right now. Highly recommend make a backup of your VM right now. Now, after you've updated. If you haven't had a chance to update your VM or install your VM properly, make sure you update. I think it's super important for you to do this. Otherwise, you can get yourself into a place where things aren't working, and that would be bad. Okay? So that's it for this for now. I'm going to pull this aside, and we'll go back to any kind of questions you have. Any questions around the installation process? Yeah, wouldn't it be nice? It would be nice. Someone's asking, or someone's in the chat. They're saying, "Yeah, I thought that if you copy the file and then you double-click somehow, it would just bring up stuff." Yeah, no, it doesn't work like that. It's not quite as easy as that. But the great thing about this is you're going to have these two files now. Linux. This is what we're going to be working with live. Here's the backup, and I have another one. I have one more that I'm going to be using for testing that has nothing to do with you guys. So worst case, I'll play around with mine. Right? And then it won't mess up yours. That's the idea behind it. Okay? Any questions around this before we continue? All right. Nope. Let's continue then. So that's this. And let's get into the PowerPoint at this point. So again, we're sitting here next week. Remember that during our session, probably on Tuesday, I'm going to host a little quiz. It's going to be based on the stuff that we talked about this week, right? And remember, we said quizzes are worth like 3% every time. So it's really worth it for you guys to come out and do the quiz. I'm going to start it pretty promptly. Right now we're sitting at 3:04. We started at 2:30. We've had a bit of a preamble to get everyone on. Some people I've seen have come in late, like almost half an hour. Guys, if you come in late half an hour next week, you're going to probably miss the quiz because I'm going to do it right away, right? Pretty much. Or at any time, right? I'm not trying to be mean or anything, but just that's how it's going to be. Notice also that next week, you're probably going to get assignment 1. It's probably going to be due in a week. It's probably going to be including anything we've talked about from a shell environment perspective. We're going to be talking about Unix and Linux shell commands, and I'm going to ask you guys to do kind of certain things there, and it's just it'll probably be a very simple demonstration about how to use the shell and some basic things. Okay, so again, there's not much to show you here. Assignment 1 is really show me your environment is what it's going to do. I'm going to say to you, I want to see your running environment. Right, so show me your Linux environment. Chances are, make sure you have these applications installed. Chances are you need to have Google. I'm just going to ask you to do some basic operations. Make Google run. Download Visual Studio Code, and then there's going to be a couple of extra applications I'm going to get you to download and install. I'm going to show you how to do it. I just want you to do it. I want to see your environment for assignment 1, as well as I'm probably going to get you to do a few commands in the terminal. Okay, so that's what's going to be happening for assignment 1. It's going to be probably the easiest assignment you might ever think of in your life, right? Which is a good thing if you follow along. One thing is, because it's so easy, I'm probably not going to accept extensions past week 3. So it's going to be due week 3, and literally all you're going to have to do is just go into the environment, show me what you've got, do a little video. That's going to be the first video you're going to make beyond the video I'm talking about. Because remember, I talked about it in week 1. Every time you submit something from an assignment perspective, I'm going to ask for a video. I'm going to ask you to go up, record something, talk about it in your own voice. You're the person who's going to do it. I don't want a computer voice. Right? I asked for a video. This is the best. I asked for a video. Someone came up with a computer voice, right? And they just used the computer voice instead. It was kind of sexy, but it wasn't what I was asking for, right? So please, yeah. Sure, thank you for that. Different flavor and from a perspective. Sure, I like it. Good. Yeah, so that's what I would say. I would say that if you could, I always have these new phrases, by the way. It comes up every once in a while, every year, things change. Anyways, so does that make sense? There's another one. Does that make sense? Is a thing that I'm going to be asking a lot for. Yes, thank you for that. So, like I said, so your video is going to come out. I'm going to look at the video, and I'm going to ask you to explain your setup, any problems you had, chances are, in your video, and that kind of thing. And you're going to show me that you know how to set up the environment. Now, if you don't know how to set up the environment, or you don't understand the VM, it's a good opportunity between now and the assignment when it's due to make sure everything is installed and working properly, because this is a hands-on course, right? This is not a course where you just watch me and learn about Linux, right? It's you doing Linux. One of the other instructors had asked, so what are you doing from a Linux perspective? Are you showing the students how to do Linux on the cloud? Are you doing Linux, you know, on you know, kind of on their machine? What are you doing? Are you setting up your own server? No, I'm not setting up my own server. That's pretty crazy. But yes, yeah, the way we're doing it is a VM. Okay, so that's the answer. Any other questions before we continue? Okay, so this is where we're at this week. So last day, like we said, we did this. We downloaded and installed. It should really stay installed. I said an ED here. Downloaded and installed VirtualBox. We downloaded the Fedora ISO. That's around 1.8 gigabytes. We created a new Linux VM, and we downloaded tools inside the VM. We downloaded 2 tools, Google Chrome and Visual Studio Code. Okay, so those are the 2 tools we downloaded. So make sure you go through that process and do your update. That's one thing I should actually add in here as well. We also updated the VM, right? Because a lot of times, not the VM but itself, the guest OS, and the reason, and that's inside the VM, And the reason why we did this, of course, is because remember, you get a package. Your ISO is been released at a certain time. And then what happens is you need to go in and update to the latest versions, just like you saw today. There was a patch release for some kind of security and stability updates, and your distribution kind of you know, control, wherever you're getting the VM, your ISO from. In this case, we're using Fedora, but it could have been Ubuntu, or it could be a Debian distribution, a distro. They would have updates on a regular basis as well. And why? Because, you know, they're trying to make their latest distribution of their version, their flavor of Linux as up to date and as secure as possible. Okay, anyone else have any questions before we continue? So that's what we did last week. So today what I want to do is I really want to talk about kind of and guys, I don't want to make this totally boring. It's a little bit dry, but it's going to be, you know, part of your, you know, some of the things you need to know from a Linux perspective. I mean, you have to know something from a Unix perspective, and where it came from, and what tools are you using. So a bit of a slide deck around that. It's not that many slides. We're looking at like a total of 39 slides total for the 2-hour time frame. So again, I'm leaving some time for us to discuss any issues with your installation and all that kind of stuff at the end, because I want to make sure that everybody has their installations running tickety-boo. And why? Because if you don't, then assignment 1 will be very difficult, and then doing anything else from here on in, you'd have to go back and reinstall and watch the videos. Okay, so that is what we're doing today. Let's start off. So operating systems. What is that? Well, it's a bunch of software, really. A lot of modern operating systems are written in C and in C++. And what they do is, it's very low-level software. It's just above the metal, and I mean that in every way. You know, from a OSI model perspective, it's on one of the lowest levels, just above the hardware level, right, where the operating system is software that communicates with the hardware on your environment. And guys, if you know this already, please forgive me. I don't expect you not to know anything about computers these days, but I got to talk about this because some people really don't know what an operating system is. An operating system is not just Windows. An operating system it could be a Linux operating system, it could be a Mac operating system, Mac OS, and it could be a custom operating system that has nothing to do with any of those, right? There are custom operating systems out there that people used, just like we noticed earlier, to hack and to do different things. Now, usually those operating systems are based on the Linux kernel, believe it or not, but there are different operating systems out there. For example, the operating system on your phone, Android phones, and your iPhone, there are two different operating systems, iOS and Android, right? Your Android operating system. So those are the two. There's two different operating systems there too. There's operating systems for other devices, and they could be built on an Android operating system. An example of that would be the Oculus Quest. Let me just pull up the Oculus Quest here so you can see it. Hopefully I don't destroy my environment. Maybe I will. Here's the Oculus Quest. So you guys should be able to see it. And up on YouTube, so the Oculus Quest, right? It runs, if you're watching on YouTube, and if you switch to YouTube, you'll see me doing this. The Oculus Quest basically is an Android device, an Android phone. And the Android phone is sitting inside the, kind of the head-mounted display itself. And what it does is it allows you to communicate, and do all kinds of stuff. It uses the screen that's inside of the headset, again created by Oculus, so that you can have this idea of a virtualized environment. Okay, which is kind of cool. VR headset. That's right. That's what an HMD is. Okay, so that is Android. All right, so Android allows you to do that. There's other ones that you can also other environments. For example, Android. The Android operating system also is used in cars, for example, to run things like car OS. A lot of times there's two flavors of that. There's a flavor for Android and iOS. A lot of devices use the Android operating system, and for example, fridges and other things like that are smart devices. They use Android in the background. And there's also some operating systems that are very, very tiny that are used inside of Arduino devices and Raspberry Pis and that kind of thing, based on the Linux kernel, believe it or not. Right? So really, really cool stuff that you can use, and it doesn't have to be in a very powerful CPU at all. Right? But there's two parts of the operating system, usually the kernel and system programs, and we're going to talk about those very, very quickly at a very high level. Again, I don't expect you guys to remember all the details, but you should know in general how things work, because that's what we're doing here. So really what the kernel is it allocates resources. A lot of times it's mostly memory. It allows you access to different devices. So for example, all the device drivers and those kinds of things, they're controlled by the kernel. Okay, and they pipe through the system programs. The system programs include the device drivers, but the device drivers communicate with the kernel, and the kernel itself, is the thing that is central. It's a control for the entire operating system more than anything else. Okay, so other things, libraries, utility programs, like it says here, shells, command line interpreters, CLIs, and all that kind of stuff. They're all system programs. So it's kind of like these two parts of the Linux operating system. I mean, to some degree, Microsoft has its own kernel, right? But it's slightly different. Microsoft's way of doing things, remember where Microsoft came from. If you guys remember, it was very similar, or if you guys don't remember, you've never learned about it. I remember Microsoft coming out, and originally it was based on something called MS-DOS, right? So MS, Disk Operating System, that's what it was. And it was just that. The DOS, or Disk Operating System, allowed you to manipulate files on the disk and run some programs. And then it was competitive with Unix at the time, because Linux did not exist, or was just in its infancy. It was just coming out, and all those kind of things. This is back in the early 90s. And then Windows 3.1 came out, which basically layered on top of, there's other versions of Windows too, layered on top of the disk operating system, DOS, MS-DOS, And what it did was it created a user interface that kind of accessed DOS. And you literally had it as a layer on top of DOS. And this is very similar to what was actually happening in Linux today. Linux, there is, it's like Linux is a command line interface a lot of times, and then we have some kind of user interface that's layered on top of Linux, and usually that is our X Window system, as well as and through the X Window system you can have different user interface shells, and one of them is GNOME or GNOME, which is what we're going to be talking about a little bit today and next week. Okay, so that is kind of a high level about the two parts of the operating system. When we moved into 1995, in that frame, and you're going to see the dates here are very similar. Microsoft got very interested suddenly in mouse and keyboard combinations as well as a user interface. Microsoft, right? Back in the day, Bill Gates was the CEO, and he was the controller of the entire company, president and CEO. And what he did was he took a look at what Apple was doing, and he said, look, we need something like this. We need something where we can have it easy to use, a system that's very similar to Apple's OS at the time, because Apple was one of the first OSs that included a mouse and a keyboard. There was also Xerox. Xerox was the first, but and then Apple took it from Xerox. And if you watch any of the Apple, history of Apple and Steve Jobs and all that, it kind of says he took it from Xerox and Bell Labs. Anyways, so but Microsoft wanted to copy that, and what they did was they created their OS as well, and their Windows was Windows 3.1 was this kind of a first foray into that, and then it became Windows 95 and 98 and Windows XP, and we have different flavors of Windows and versions of Windows throughout the years, with notable bad versions of Windows like Windows Vista and Windows 2000, which we don't speak of in any circles anymore. All right, but we do speak about Windows 10, because Windows 10, which is interesting how it maps alongside with Mac OS 10, Mac OS X also is what it's called. It's something that's probably the most stable operating system that's been out there since Windows 7. I think Windows 7 and Windows 10 were good. Windows 8, not so good. But these different flavors, these different versions of Windows keep improving upon the user interface to make it easier for us to use our computers, right? Because again, a lot of people find it very challenging, and we're going to see that throughout the entire course. They find it very challenging when it comes to using a command line interface, a little window, a terminal window, to make all the commands happen. It can take a long time, whereas we're so much more used to now just dragging and dropping, double clicking, all these things to open up a program or to use it. Because really at the end of the day, people who use computers, most people are not programmers, they're users, right? So that means they need to be able to use the computer very quickly, and understand how to navigate in and out of programs. Okay, so we that's what it does. So the system programs kind of act as they kind of communicate with the kernel, and the kernel itself, Linux kernel, or one of them, was developed by this guy Linus Torvalds, right? And Linus, he was actually an undergrad student when he developed this way back in 1991. Okay, in 1991, I remember those years. I do remember. I'm an old guy, right? So 1991 was an interesting year. Again, Microsoft was chasing Apple with their Mac OS, and I remember Unix was something that, and it's going to say that here, Unix is more or less a university kind of operating system, something you got at university or college, and it was supported largely in enterprise environments. All right, so you wouldn't have a Unix operating system at home. I mean, remember that the hardware was not as small as it is today. I mean, back in the early 90s, we're talking about the hardware that would be required to virtualize and to broadcast live like I'm doing today would probably take most of the size of my house. Okay, that's how big it would be. it'd be massive, and very, very expensive, you know, to run. Laptops, you gotta. I'm just gonna try and phrase it for you. Laptops were non-existent for the most part in early 1990. All right, I mean, for you to have a laptop, you probably had, you know, a $10,000 machine in your hand, and it was very basic, blocky, probably about I would say 2 inches thick, right, or more, and pretty heavy, right? And it also had an exterior power supply that was pretty heavy duty, right, like a block, right? Not unlike what they have today, but heavy. And it got hot, and they broke down easy, and so it was rare. In the early 1990s, we're talking about cell phones were just you know, starting to become more mainstream. So you get to figure that there's a lot of technology that we take for granted today that didn't really exist back then. And the same thing goes with things like the internet. That was not, it was just being born around that time, ARPANET and all that stuff. So this all happened at the same time. So Unix was popular, but Linux didn't really exist yet until Linus Torvalds kind of came up, and inside his undergraduate years, he created his own version of Unix, if you will, and it was Linux. And he kind of made Linux out of his name, Linus, and Unix. That's where it came from. Okay, so there you go. There's the kind of a very high overview of where the word Linux came from in the first place. Also, one thing to note is that Linus didn't start from a vacuum. He didn't just like make his own stuff. He didn't go into the Unix operating system and pull things down. What he actually did was he based it on something else. All right, so there is a software foundation called GNU, right? And the GNU project, we're going to talk about that in a second. And the GNU project had this philosophy that of about free software, and they kind of talk about it here. Free software is a matter of liberty, not price. To understand the concept, you think of free as in free speech, not as in free beer. And this is actually, I have to say, I know I have colleagues of mine who are very much into this idea of free software, of anonymous, you know, kind of presence on the internet, and that kind of stuff. They do not like the heavy-handedness of Microsoft and Apple, and they avoid all Microsoft and Apple products so that they don't ever get an iPhone. They will never run Windows. They'll only run Android and only certain versions, and they'll only run Linux as an operating system. And for their browser, Firefox would be the very most they would run, if not DuckDuckGo. Okay, that's just the way they are. And the reason for this is because of privacy, right? Because we are being tracked. And one of the things that you can do with an operating system like Linux is you can turn off all tracking. You can fully control the operating system. You can control how it's built. You can make your own version of the operating system that is only for you. There's a lot of control. It takes a lot of know-how, and you need to know how to program in C and C++, but it can be done if you really want to. And I think that is the great thing about Linux. It really, you know, supports this idea of free speech and free software, which I really like. The idea behind it is really cool. All right, so let's keep talking about this history of Unix and Linux. We kind of jumped ahead a little bit when we talked about it. But more or less, back in the day, universities and colleges were the main players from a Unix perspective. Unix was created so that it was free. And what happened was, when it was released back in the day, and you can see this was back in 1975. It's been it's been around longer than I was at college and university, that's for sure. But I remember we used a version of Unix in my day called Citrix. And we're talking about back in the 80s and 90s when I went to university for the first time, and it was used as a version of Unix. We learned how to do it, and it used a system even back then to compete with Windows 3.1 called X Windows. So I was using X Windows probably late 80s, early 90s. Okay, when I was using it for sure. So, and I mean, again, you got to figure out that some of the functionality that we had back then, Netscape Navigator instead of anything like Chrome or Firefox, these browsers didn't exist. The internet, as we know it, didn't exist. It was something completely different. You know, and it was very, very slow. So that's something to note, right? It was hard to get your hands on free software back then because it was all done through bulletin board systems and different kinds of forums that you'd have to dial into, actually, more than anything else. Okay, so Unix, you know, kind of was the first, and it offered this idea of a kernel and system programs. And it was popularized and supported by the U.S. government. The U.S. government wanted something that was robust, and they also wanted a convention to base all of their software on top of. And of course, we had this idea of BSD, Berkeley Unix, which was kind of a distribution, a version. So when you see BSD, it's a Berkeley software distribution. It's a version of Unix that was created. There was the other major version of Unix was System 5, which is SVR4, which is what it was, which basically was used by things like AT&T and other Unix system labs. I remember that back in the day. Okay, so those are different versions of Unix. Again, primarily a command line interface environment at this time. Okay, so we're not talking about a lot of user interface at all. Along comes this dude, Richard Stallman, right? And he starts thinking about this, project, GNU, right? The GNU project. And actually, if you look at stallman.org, you'll see that he talks about, the GNU project. And what he did was he created, he's been credited with creating the Linux kernel, the GNU kernel, GNU Unix is what it was called, and system programs. And this is what Linus Torvalds based his version of Linux on. He actually completed the kernel that was out there, and he used the kernel to make his own version, and we'll talk about that. One thing he said was GNU, which stands for GNU's Not Unix, is a recursive acronym. Actually, that's what it is. GNU's is almost like a weird looking cow, right? It looks kind of like this. This is the GNU, and it was based on a song that he was into. He's a little bit esoteric, Stallman. So 1991 again, the GNU operating system was out there, and so it says early 90s. And so he says we had put together the whole system aside from the kernel, and we were also working on the kernel, and he called it the GNU herd, like a herd of GNUs, right? Which runs on top of Mach 4. This is what he was working on. And of course, what ended up happening was that Linus completed it and made his own version. And if you listen to what Stallman says, well, he just took what we had, and there's versions out there, and he made his own, right? But he's been credited with. Sorry, just dropped my mouse. He's been credited with being the inventor of Linux. But then again, Richard Stallman talks about how he had definitely a hand in it, and he definitely had some kind of hand in creating that software back in the day. So again, the GNU operating system runs on top of FreeBSD, which is and NetBSD. This is what those two they're out there, and there's two different organizations that are definitely looking at the creation of free software, and each version of the GNU operating system, this Linux base or kernel, if you will, creates different distributions, and that we're going to talk about. So sometimes you might have some versions that are based on FreeBSD, and another one that's based on NetBSD, and it's just a different version of the kernels. And that's why when we look at things like Debian and Ubuntu, they're kind of placed together. And then you have Fedora and OpenSUSE. They're also placed together because they use different versions of the kernel that was created back in the day. Okay. One other one is Darwin, which is another kernel that's basically used for Mac OS. Okay, this is another distribution of the kernel. That is what Macs use, Darwin. Now, I'm not sure how long that's going to last. If you actually read anything about Mac OS's in a while, you're going to see that things have changed. That Mac is looking to move towards more to try and install iOS-like version even on their MacBook Pros and their Macs. I really hope that doesn't happen. And also, sorry, my internet says I'm unstable. And when my internet says it's unstable, you know what that means? It means that it means that somewhere down the line things are unstable. So you might get a bit of lag. So anyways, yeah, so what they're talking about at Apple these days is maybe moving away from the Intel architecture altogether and moving towards their own architecture, their ARM processors. So that means that there's a high chance that they're going to move so that all their software is compatible and proprietary, and their hardware is going to be proprietary again. Apple moved through this phase where everything was proprietary. It was completely different than PCs. And nowadays, if you take a look at the guts of a Mac and the guts of a standard PC, they're pretty much the same. They're using an Intel architecture for the most part. They might have an AMD graphics or graphical processing unit, so GPU. The memory is the same. The SSDs are the same. Everything is exactly the same. The chipset is Intel's. Everything is the same. But back in the day, that wasn't the truth. Back in the day, they had their own proprietary hardware, and it was part of what Steve Jobs wanted to promote. You couldn't get any parts from anywhere else for Apple products other than Apple. And this is part of his business magic that he kind of thought about. He thought about ways of making it so you would buy Apple from Apple. You couldn't swap in parts and all that stuff into your machine from some other manufacturer. And then slowly they moved away from that. That battle was lost, and they went back to this non-proprietary stuff. It was specially made. The MacBook Pros and the Macs were made so that they were, different versions of a PC. So they have specific hardware requirements that the operating system would know about. Remember that it's based on a Linux kernel, so plug and play and understanding what's been plugged in isn't the same as Windows. Windows, you can hit Microsoft for a bunch of stuff, but I'll tell you right now, if you plug something into Windows, it'll try and figure out what it is. Not so with a Mac, especially older hardware. If you try and plug in something old on a Mac, let's say an old Wi-Fi card or something like that, if your Mac, your version of Mac doesn't understand what that is, it'll be like, I don't know what that is. It won't even give you a beep. It won't say, da-da-dim, I've got something new. None of that, right? That's a beautiful thing about Windows. But you can, not to say that there isn't a beautiful thing here about Linux. The great thing about Linux is you only add drivers and support for hardware that you need, right? And that's it. And in fact, if anything, the good thing about Linux is it's minimalist. It can be. You can make it so it's very, very small. And there's some distributions out there that you can get that are stripped down versions of Fedora. There's stripped down versions of Ubuntu and other flavors of Linux that are very, very small. Okay. And like we said, they can even run on things like an IoT device, like an Arduino or a Raspberry Pi. So again, I have to keep saying this because this is one of the key elements, if you will, or the core of why Linux is the way it is. It's free. Everything inside Linux is free. You can take a Linux distribution and you can do whatever you want. Thank you, International Game Developers Association. You can do whatever you like to do with it. You can make your own software. You can, you can design your own shell. There's many things that you can do, and they encourage you to do that, as opposed to, they're not as pedantic or as draconic, let's say, as other places like Microsoft. Microsoft is not free software. You have to download it. And although the Apple operating system is technically free, you have to have an Apple to run it, a Mac, an Apple machine, right? So it's not really free, and it doesn't work on every all the hardware you'd have. There's a lot of work to do to build a Hackintosh, right? So like I said, it's something that you have to work really, really hard to. So again, the code is free, and I think this is a central theme of Linux in general. Code is free. So back in the day, again, two professors created their own stripped-down version of Unix lookalikes for educational purpose. One was called Minix, and the other one was called Xenu. All right, and then Linus, basically, he created it Linux to counteract the shortcomings of Minix. Minix is almost like a minimalist operating system that had very simple features. It lacked a lot of stuff, and what he wanted was to have it feature-rich, feature-packed. So it wasn't just an operating system from an assignment perspective for assignments, but it was also for the general population. So this is a different philosophy, let's say, than some of the other projects that were out there at the time. Okay. So again, and they say this clearly, although Linux itself is the name of the kernel, so the kernel is called Linux, the way we package the kernel, right, whether we have a flavor of Linux, the Linux kernel with other system utilities and projects or programs like, for example, Fedora, it's still the Linux kernel with just additional things around the kernel for you to connect to drivers, for you to download the different packages from the internet and so on. And we're going to see that in the weeks to follow. We have to talk about some keywords. One of them is called distribution. A distribution is just the kernel. It packages the kernel and programs that are associated with the kernel for different flavors of Linux, and these are called distributions or distros. Okay. In addition to those things, you also have mostly the X Windows system in some form or another, which is a layer just on top of the command line interface that allows you to use graphical user interface tools such as GNOME. Okay, and there's other ones out there too. We also have to talk about some other terms like FOSS and FLOSS. Those two terms you should kind of know about as a developer. FOSS, free and open source software, and FLOSS, free Libre open source software. Both those two projects, are those terms kind of denote free and open source software, and they were brought into common use just after the OSI, the Open Source Initiative, was formed. And if you look at opensource.org, it'll talk about that. Opensource.org is interesting in that they have a lot of standards, and they go to the community. They have a lot of community support. For example, the OSI model comes from Open Source Initiative, right? Which is kind of interesting. And if you guys should know about the OSI model if you've done any kind of computer hardware at all. Okay, let's continue. So what's good about Linux? Like, why would you use Linux? Why not use Windows the whole time? Well, we talked about this at length. It's free and open source, and it's secure. It can be private. It's open and it's a community project. For the most part, you can get different versions of Linux for free, right? There are some versions of Linux that are proprietary. I have to talk about those as well. And they're used primarily in organizations like banks and those kind of things. But those versions of Linux, they have different kinds of support, or they have a Linux-like system that they've built that's proprietary for their back-end servers and so on. And I have to tell you this: Linux is probably the #1 back-end for servers, for web servers, for game servers, for all kinds of stuff in the back-end. Why? Well, it doesn't have the same bloat as Windows. Take a look. We had something that was our operating system was 10 gigs so far, right? When have you ever loaded Windows 10 with 10 gigs? And the answer is never. I mean, I don't think I can ever run Windows 10 with less than 40 or 50 or 60 gigs, right, of space on my hard drive, right? So that's a real thing. It's really small. It's much smaller than what we're used to. Files in Linux are very small too, right, compared to some of the larger files that we see on the Windows system. Now, I don't want to knock Windows. Windows has reasons for doing what they're doing. They're so generic, and they've made a monster of an operating system that's so big that it can work on almost any hardware, and it'll detect all automatically detect the hardware drivers that are installed inside the manufacturer's EPROMs inside of their devices. Even a brand new device that that just came out, Windows will detect it. And a lot of times, a lot of these devices are so smart, they'll go up on the internet and download their own drivers for you. It doesn't do that with Linux. Linux, there's a bit more hands-on involved from a Linux perspective. It doesn't happen automatically. And this is for two reasons. One, it wasn't designed that way. It was designed to be, you're going to control everything. Linux is like, you have access to have more control over the operating system. You have access to privacy and so on, and you can use the capability of your hardware at speed. It's very, very quick, right? Linux, and as a server, for the most part, it's probably quicker than Microsoft servers if you're running Windows Server, pretty much, right? Nowadays, Microsoft has also optimized things, so they're very, very quick. For a long time, Microsoft was against free and open source. They didn't believe in the project. And only just recently, I'm saying within the last 5 years or so, has Microsoft said, yes, Linux is a good project. Yes, open source software is okay, right? Because before, Microsoft was an opponent to open source software for many, many years. Okay? Just pointing that out there. So, other things that are good about Linux, standards. Basically, one of the things that is great is that the POSIX, which is, I have to talk about this again, the Portable Operating System Interface for Computer Environment Standard, which was basically, it came out of Linux, and basically what they created is a grouping of IEEE standards that really defines things for APIs, for application programming interfaces, which are pretty awesome, right? So a lot of stuff came out of developing Linux. So standards was one of them. Applications, right? One of the things that Linux came out with, because they believed largely in these small little applications that run on your system. It wasn't about large applications. Every application did one thing, right? So things like, and by the way, all the applications that you find on a Linux system, like LibreOffice, are all free and open source. You can take them, modify them, make your own versions, and so on. It's totally up to you. So a lot of application development happen on the Linux system, especially from a university and academic perspective. Tons and tons of them. And new applications are being created every day, right? Very, very small ones that do specific tasks and so on. So that's a great thing about Linux. One thing about Windows, if you want to distribute your application on Windows, nowadays it's become easier, but back in the day, making it available through Windows, there was a cost. There was a cost you had to pay to Microsoft back in the day, and then later on they relaxed that, right? So again, if you think about Linux, if you think about anything about Linux, think about free. Think about free speech. Think about free software. Think about free coding. And this idea of freedom is the reason why there's a lot of developers out there that are in so much support of Linux, and they're against things like taking away net neutrality and all that kind of stuff, because they believe that we should have free and open access to information technologies across the world, right? And I'm one of those people. I really believe that's the case. We should all have access to information, every one of us, everywhere. Let's continue. Linux is portable. This is another one. And the great thing about Linux being portable is you can literally make it as small or as large as you like. It's hardware agnostic. It really doesn't care what hardware it's put on. And the reason why it's so portable is it's written in the C programming language for the most part, 95% of it. And C is a general language that can be run almost on any device. Any computer device, right? So even on your iPhone and on your Android phone, if you really want to make your own operating system that runs on the C programming language, or like a little mini version of Linux, you could do that. And in fact, iOS is based on, and so is Android, the Android operating system off of the Linux kernel, more than anything else. Okay. And of course they would be, because both projects, Android and iOS, started with Linux. Okay, so here's an overview of Linux. So we've got the Linux kernel, and it's just above the hardware, like you see. So here's your hardware, and just above that is Linux kernel. And above that, you'd have things like compilers, database systems, and all the software that you'd normally be used to. Okay, that's how it works. So Linux kernel is almost like the middleware that connects with your hardware. Okay, more than anything else. Again, these images come from the book for the course. So one thing is that you can, it has a kernel programming interface that you can make and adjust the kernel and add, or adjust the kernel to work on different hardware. You can add different things so that it can connect with different devices. And there's a whole application programming interface that's associated with the kernel itself. The other thing is that Linux can support many users out of the box. Back in the day, you got to remember that Microsoft was not, and that was the competing operating system, Microsoft and Apple. They were not networked at all in the beginning. Networking was added much later, and it was added as an afterthought, especially for Windows 3.1. There was a version of Windows 3.1 that had networking, and they originally called it Windows NT. Of course, Windows NT morphed into Windows Server later on, but really, even Windows 95 by default didn't really have networking. You had to install the networking components, your Ethernet card and all that kind of stuff. By the way, there was no Wi-Fi at the time; it was just wired connections. So Linux was made from the get-go to serve more than one user. So more than one user could use your computer. Back in the day, again, you got to think about this when I say back in the day. It was way more expensive to have hardware, and remember that there was this prevalence of terminals, dumb terminals, at different places that would connect to mainframes. And why did that exist? This centralized system where you have client and server, and the client is literally a dumb terminal, and the server is running some flavor of Unix on the background. So you log in with your user account, right? And you're using the same hardware as everybody else, right? And so you're sharing the hardware costs, and you have your own user environment, your own user space, your own profile, and so on. That's all the stuff that was done back in the day with Unix. And Linux takes that same, kind of concept and distributes it across the world. So when we build our little Linux workstation, we could have multiple users, and that's built from the ground up like that. Whereas, again, Microsoft originally was an add-on. It was just an afterthought. It was, hey, we need more users. What if someone else uses my computer? What do we do? So Linux from the get-go started with security in mind. How do I secure my environment? How do I, create, almost like a jail, if you will, that my user can't get out of, right? He's only allowed, or she's only allowed, to be in this little environment, and depending on their administration level, they can only do so many things, right? They don't have, by default, super user access, and we're going to talk about different kinds of access later on in this course. But that's how it started off. Linux from the bottom up started with supporting multiple users, and a multi-user operating system was a special thing back in the day. Nowadays, Windows 10 and other operating systems support multiple users. Linux can run many tasks, and you might think this is not a big deal anymore. But back in the day, going back again, Windows and even Apple's OS was not multitasking. Although Apple's, I believe, happened a lot earlier. And before that, we had another version. Remember that there were other companies that have gone away, didn't survive. One of them was CBM, Commodore Business Machines. And Commodore made a couple of computers back in the day. One of them was the Amiga, which was the predecessor in many ways to some of the computers we see today. And it was one of the first multitasking operating systems that they used. They had their own operating system. It was nothing to do with Linux or Unix or Microsoft. It looked very similar to DOS. It was called Amiga DOS, actually, Amiga disk operating system. And they also had Commodore DOS. Commodore is where Microsoft and Commodore was kind of using the same operating system back in the day. But they weren't they could not do multitasking. So, and what is multitasking? Is it parallel processing? Does anyone know what multitasking is? Is it running things concurrently? What are these words I'm using? You should kind of know some of this stuff, guys, for the people that are out there. Multitasking, yes, you know what it is? What is it? Tell me, Rosalie. Doing a lot of things at once. That's like parallel processing, and that's like a different thing, right? Think about multitasking as switching between tasks, almost like a task switcher back in the day. So you can run many apps at the same time, but what you would do is you'd have a manager, a process manager that would switch between tasks. That's all it's going to do. Nowadays, we use processes and threads. So we talk about a multi-threaded application as an example. Each processor has multiple threads that it can run at the same time. In a multi-core processor, you have one processor and multiple threads. So if you had multiple cores, then each core could run its own processes and its own threads. So it's very interesting. Back in the day, we didn't have that kind of stuff. It literally had one big process, and you would switch between tasks. That's what it would do, right? And I'm just being very, very high level at this point. So nothing, running things concurrently, doing many apps at the same time. These are the same kind of things. So Linux did that right out of the box. Linux was a multitasking operating system right from the get-go, and it keeps track of multiple processes. Nowadays, it's a multi-threaded application, so it can run multiple threads. And each thread is running could be one part of a task or a process. And we'll talk about some of this as we go into the course. Okay. So another thing is it provides secure hierarchical file system. A secure file system, and it says figure 1.2, and we'll see what figure 1.2 looks like in a second. It's secure in that it puts you inside a box, like we talked about. Each user, when they log in, they have access to their files, and there is a hierarchy. You have a file, which is a collection of information, like it says, and instead of folders like we have in Windows or on Mac, Linux calls them directories. Okay, so that's something that we have to know. So if I say directory, in your mind, you should think folder. Okay, it means the same thing. And this is what it might look like from a directory perspective. You can have, inside of a directory, you can have files, and you can have other directories. And this is where the hierarchy for Microsoft's operating system, as well as Mac, came from. It came from the Linux roots. Where all these, the file hierarchy came from back in the day, right? It came from the same place. So use the tree-like structure. So you notice the first part of the tree-like structure is at the top, which is this slash. And a lot of times slash means that's the root of the tree. We talk about root, and then you can see that there's other directories. You can see that the home directory has 3 other directories: Max, Sam, a couple of user, and some other directory. And inside of that directory, you might see some other directories: a bin directory, a report directory, a log directory, some notes, and so on. And this is the way that this is what happens in Linux. And again, you are used to this if you've been using any kind of machine over the last few years. You know that this is kind of the structure that runs in your machine as well, whether it's Windows, Mac, or Linux. Okay, but they did it first back in the day. They also, Linux uses a shell, a command line interpreter programming language. There's different shells that are very common. One of them is called the Born Again shell, Bash. And we're going to talk about the Born shell, which was the original Unix shell. All right. There's also another one called Debian Almquist shell, which is also known as Dash. So Bash and Dash. There's the TC shell, or TCH, which is a very common shell as well. TCH is a lot of it. I've seen a lot of this in on a Mac system, and you can also have Z shell or ZSH and that's my favorite. I use a version of iTerm on the Mac, which runs ZSH. It's a different kind of shell, and each shell that we're going to be talking about, mostly one of them, Bash, for the most part, as we go through, you're going to see that a lot of these, when we do shell scripting, what we're doing is we're talking about command line interface, and when we can run little shell programs, some of them that run automatically, right? So we'll talk about that. By the way, we can also use shell scripting to run scripts automatically on startup. A lot of times, Windows and Linux and Mac have these little scripts that run automatically, and we'll talk about what those are. Almost like little macros that run. So I'm just trying to use words you might have heard before. Okay. Don't be afraid. I know some people are afraid of command line interface, but it's something that we're going to all learn how to do this semester. So if you say something like, well, I never knew anything about command line interface. Well, the expectation for this semester is that you don't know anything about command line interface. So we're going to learn that together. So some of the things I'm going to ask you to do for your quizzes and for your assignments is things that we're going to talk about together here in the course. Okay, so it's not like you have to know something on your own. You can certainly read the book in advance if you'd like, but really at the end of the day, I'm going to be going through everything with you anyway. Okay, so different kinds of shells. And UIs, graphic user interfaces. So again, the X Windows system, also called X. All right, I know it was. They had some interesting names: C, X, D, R. You know, all these different names. They're like one character names. And by the way, back in the day, you could also get a domain for on the World Wide Web that had 2 characters, right? As an example, HP is a good example of that. You can't do that now; they're all gone. Those top level domains, right? But yeah, a lot of programmers are minimalist here. X, I want to make the X Windows system, right? And X Windows, again, I think at the time, hardware manufacturers borrowed from each other. And I'm not sure if Windows was first or X Windows was first in this case. I remember using X Windows in university, again, back when I was doing university, and I was amazed by it. I was like, wow, hey, this is really good, and it's solid, and it doesn't crash like Windows 3.1. But that's like comparing, I was actually running or playing with a jet plane compared to running Windows 3.1. Why? Because it was running in a mainframe, and the mainframe was like a room in the university. It was huge, right? And it was connected to the internet, right? And I was running really, really fast using fiber back in the day, like crazy connections. And you couldn't get that at home at all. There's no chance that you can do that. So running anything like that on a computer at home was a dream, a daydream, all right? And of course, nowadays we have all kinds of stuff that's way more powerful. Probably my watch is more powerful than some of the stuff that we had, that took up a room in the 90s. Right. So anyways, again, so graphic user interface, we had X Windows as a base, and then on top of that, we had an environment, a Windows environment, and those Windows environments, there's 2 parts of them. One part is the desktop manager, as an example, and the desktop manager we're going to be using this semester is called GNOME or GNOME, all right, depending on how you want to see it. And then there's the window manager, and the window manager, what it does is it allows you to do things like it creates a personality that allows you to change background colors and settings for your environment, so you can make it more comfortable. You can customize the look and feel of your user interface, and that's your Windows manager, your window manager. Okay, so those are the 2 parts, 2 programs that live on top of X Windows. So X Windows or X, it runs as a base level just on top of the command line interface, and on top of that, you have your GNOME or KDE. So what GNOME is a default desktop environment for Fedora or Red Hat Enterprise Linux. That's what it is. It's a simple user interface that we kind of installed last day, and that's what we did. It uses GTK. GTK is a set of drawing widgets that allow things to fire off, and it was developed a lot of times for something called the GNU Image Manipulation Program, or GIMP. You may have heard of GIMP. Some people use it as an open source drawing program. I think it's okay in general. If you're an artist, you might want to try and use something else than that. I think there's other programs out there that are very good as well. One thing is that most programs that are written for Linux are written in C and C++, sometimes in Java. Why? Because they are portable. They can be moved from one distro to another. Okay. And that's really it in a nutshell. Those are the most things I want to talk about today in terms of a history of Linux. I wanted to keep it. Wow, that's really weird. Yay! Reconnection successful. Sorry. Isn't that interesting? I'm running a crazy amount of bandwidth, but keeping a stream nowadays in COVID-19 is very challenging. All right. Whereas I'll tell you right now, when I was streaming normally, it's no issues. Right. Okay, so lots of collection of useful utilities, and these utilities are built into the command line. Some of them are things like sort and info and man. By the way, man pages, that's what they were called before, is a manual for how to use every command that's installed in your Linux operating system for the most part. Okay, so that's man. And we'll talk about how to use these things as we go forward. Okay. So we've taken care of the first part of what I wanted to talk about today, which is a history of Linux, a little bit of my own preamble in terms of like what my experiences were back in the day, and I think hopefully you got something out of that. But at the end of the day, that's kind of how things go. I want you to understand, I think, which is more important to me than anything, the evolution of some of the systems that we have today. So when we actually use Linux, you have a good understanding about where it came from. And so if someone was to talk about this with you in an interview, then you can talk about this. You can have some kind of conversation. These are important topics to understand. And I think every developer should know a little bit about Linux, because this is the platform of choice for developers from an open source perspective and to develop free software. So really important to do, guys. I'm super excited to be doing this with you guys this semester. And why? Because we have a chance to do this together. Okay. Any questions around the history of Linux? That's all I'm going to do. I'm not going to do anything deeper than this. I think this was even too much, in my opinion. But I wanted to talk about it with you because I think not knowing where the software came from, not understanding how the tools were developed, would really hamper your development, I think, as a software engineer or a developer. Even if I'm not sure if some of you might be on the networking stream, I think it's really important to understand those things. So any questions at all? Oh yes, I'm going to talk about the video assignment for sure. I'm going to talk about it right now. Absolutely, you will be learning Git this semester. I'll be talking about Git as we go forward. So whenever we have most likely in the second half. And the reason for this is because we'll be using Git for you to get software. I'll be sharing software with you guys on GitHub. So everything you submit with your assignments will be using Git. So we'll talk about how to use Git, how to download stuff, and the whole thing. Okay, that'll be in the second half. All right, so if there's no questions about the history of Linux, let's move on to what I want you to do, a special project that I want you to do for me that I'm willing to pay 5% bounty for. That's a 5% bonus, right, on top of everything else. So that means you could literally miss like a quiz, and if you did the bonus, it would make up for that, right? I'm okay with everyone doing 100% on this one if you're into it. It's a good exercise because there's a couple things in it for me, like I talked about. One of the things that's in it for me that's super important is the ability for you to produce a video online every assignment. Okay, that's the important thing for me. And if you have me at all as a professor at Centennial for the next little while, I'm talking about probably until the end of 2021, right? I'm probably going to be asking you for an assignment, right? That has a video component to it. Why? It gives you a chance to almost do like an oral exam, right? So tell me about your knowledge about the stuff, which means you need to know what you're talking about. I think it's going to make you guys super strong. It's going to make you understand the concepts very deeply, right? So I think I'm paying you to learn how to use the tool, and I'm giving you a bonus. Okay? So this is my bonus for this semester. So what are you going to do? And this is the personal demo video instructions. Okay, and I've kind of removed this. I'm going to talk about this is already up on eCentennial. If you actually go eCentennial, there is an assignment like this, almost exactly, and it's due next Tuesday. Okay, so let's talk about this. So 5% bonus for this semester only. Task 1, make a slide deck. First thing. So make a very simple PowerPoint document, or you could make it in Google Slides, or you can use LibreOffice if you want to try that with Linux. That would be interesting to do. And I want you to put together 4 slides, 4 simple slides, for you to do this. So the first, and by the way, for you to get the 5%, I got to mention all the parts have to be in place that I'm asking you to do. So it can't just be, hey, here's my slide deck, but no video. And here's my video with no slide deck. If you do a video with no slide deck or a slide deck with no video, I can't give you the 5%, guys. It's got to be all or nothing. Why? Because it's 5% bonus. I'm getting you to do it. And there's an underlying reason for me to get you to do it, right? So you need to have all these parts in order for you to do it. Title slide. It must include your full name, your student ID, and a current image of you. I don't want avatars. I don't want an image of your favorite actor. None of that stuff. It has to be you, right? And that means that you have to go and get a picture done, right? It could be someone taking a picture of you in your household, or you could take a selfie. As long as it's legible, I recommend black and white, right? You don't have to use color. And why? Black and white hides a lot of the defects that we have, especially now with COVID-19 hair and all this other stuff. So you can get it done in black and white, and it'll be looking pretty good. But however, you can make it whatever you like if you prefer color. It's got to be a view. I'm looking for a heads and shoulder shot. Okay, I don't want an image of your whole body, just a head and shoulder of who you are. Okay, so just to see your face. And so this is you. This is your student ID and who you are, right? Another slide. Slide number 2 is about me. Okay, so about me. Who are you? Where are you from? Right? Are you from Toronto? Are you from India? Are you from Pakistan? Are you from the Philippines? Are you from Brazil somewhere? Where are you from? Okay, and you can be as brief as you want here. I don't want you to go into detail about too many things, and especially if you don't feel comfortable with talking about some stuff, talk about the things you feel comfortable about. Okay, so who, where, and I didn't highlight why, but why should also be bold. Why are you enrolled in your program at Centennial? Why did you come to Centennial in the first place? If you want to have another slide about these things, you can have an additional slide. You can have more slides than these, but these are the minimum that I'm looking for. Okay, these slides. So that's slide number 2. Who are you? Where you came from? Why you're here? Kind of stuff. Third one, projects and interests. What are you working on? Are you working on a specific project outside of school? If you're not, what are your interests in software and technology? Are you interested in machine learning? Are you interested in VR? Are you interested in networking? Are you interested in security? Are you interested in big data? Are you interested in health and informatics? Why are you here? What are you interested in doing? What do you want to do? Kind of stuff. Why? What projects are you working on? If you're working on a project, if you're an intern somewhere at the same time you're doing this, or if you're working part-time somewhere and doing this, or you have a side project you're working on and doing this, talk about those things, because this is what makes you interesting. And the last slide, which is the future. I want you all to look into the future. Hey, this is my 5% project, so I can ask you whatever I want. So this is what I want. I want you guys to look into the future, and I want you to tell me your vision of the future in one slide. Okay? Where do you see the world going, and where do you see yourself in it? Okay? Where are you? Do you see yourself in the future as a software engineer? Do you see yourself as a game developer? Do you see yourself as a VR developer, an AR developer? Do you see yourself working with autonomous vehicles? Where do you see yourself? Right? And like I said here, this can be creative. Be creative, right? But I want it to be about you. So don't put stuff in there that's science fiction, that's never going to happen. Try and keep it within the next 5 to 10 years in your mind, because that's where you're going to be. You're going to be landing a job, and probably somewhere deep in your field between 5 and 10 years from now, right? So you'll be, obviously getting a job sooner than that, but getting into it and developing yourself into a senior developer somewhere my thoughts are probably 5 to 10 years, right? So that's your task number one. So task number one, create a video. Create a deck. So I'm just looking at the questions here. Some of you are saying you're probably going to have me as a JavaScript teacher as well. Yes, I will be teaching COMP301 in the second half of semester. I think I'm going to be working with Patrick. He's in the first half. Okay, so I do things a little bit different than Patrick. So chances are what I'm going to ask you to do is become JavaScript rock stars in the second half. So if you're interested in a challenge, and if you've got me for for JavaScript, then yeah, it's going to be pretty challenging what I'm going to get you guys to do. I mean, we're also going to use Visual Studio Code, which is good, right? So if you're here and you're also doing my JavaScript course, then chances are you'll be doing Visual Studio Code a couple of times, all right? What else? I also say, can I, instead of a pic, can I use my webcam to film myself talking? Yes and no. Yes, you can if you use OBS. Like for what I'm doing right now, broadcasting live, you can use your webcam, but I need a picture of you anyway on your title slide. All right, so if you want to keep filming yourself through the entire time, like I'm broadcasting now and streaming live, you can do that, and I can see your face. But I'd want a picture of who you are on one of the slides, just like kind of how I did on day one, where I said, hey, here's me, here's my picture, and I'm here. I've been doing this from 2011. So that's task number one. Task number two, after you make your slide deck, record a video that captures your slides and your voice. You can use tools like OBS, which I recommend. This is the tool that I'm using right now to capture everything. So OBS, let's go to that tool right now, and let's see if I can pull that in. So I'm just going to pull our browser in here. So OBS. So if you look at OBS, it's called Open Broadcaster software, and it's available for Windows, Mac, and Linux. Now, I'm not going to tell you that I recommend doing it with Linux, because sometimes what happens is whenever you use a VM, if you're using a VM to produce software, again, you got to connect your webcam, and you got to make sure your audio works properly and all this kind of stuff. It might be just easier to do it in Windows. Okay, that's all I'm saying. If you're capable and if you push yourself to learn how to install your hardware properly on your VM, or if you're using a dual boot and you want to do it anyway, or if you installed Linux on the Metal, all the power to you, then that's great. I don't mind any of that stuff, but I recommend something like OBS, and the other one is Camtasia. So if I look at Camtasia, those are probably the two that I can think of that are not a big cost, that have trials and that are mostly free. So Camtasia is another big one, and you can download a free trial for this one. This is more of a cost involved to this one. But I find that Open Broadcaster is just fine. I mean, I do most of my stuff with OBS, and it's cross-platform. I use it on the Mac as well, although it's a little bit slow on the Mac. Warning, you do need a pretty good system to broadcast live. But one thing that OBS will do is, and there's some great tutorials on how to use OBS out there, by the way. One job you're going to have to do is go online, take a look at some tutorials to set up OBS. When you download OBS for the first time, it'll kind of talk about how to set it up. But more or less, if you notice down here in the sources area, there'll be a sources. You can specify which sources you want, right? I'm not worried so much about scenes. I usually just use one scene. Okay, that's normally what I do. However, there's nothing wrong with using multiple scenes if you want to cut from, kind of an opening scene to the play scene to the end scene where there's credits and all kinds of other stuff. People are very creative with this. But really all you need is one scene, and inside the scene you can have several sources. Each of these sources could be things like your display capture. So things like, as an example, I want to do, I have display capture 1 and display capture 2. I'm going to show you my version for a second. When I do, you're going to see almost like a mirror effect. Okay, so just don't be, don't get angry. So this is me. This is what it actually looks like now on the internet, right? So this on YouTube, so you can see that my face is being copied over. But I'm using basically only 3 different sources. I'm using a video capture source, which is my webcam, and I'm using 2 displays, and I can always switch between one display and the other. Notice this display capture 2 is the display that I have all the other tools that I'm hiding, things like Zoom and all that kind of stuff that I don't want to show your identities on. I leave that on display number 2, and on display number 1 that's the thing that I'm capturing right now. Okay, so that's the kind of stuff that you're going to be seeing when you set up OBS on this left side here. Highly recommend. Yes. Are there other ones? Screen recorder. There's a ton of them out there that'll do the same thing. Am I going to be taking over the second half of the course of the semester for COMP301? Yes, I will be. Absolutely. I'm not sure if it's going to be for all of the sections, but for one of the sections, I think it's section 4. If you look me up, there is one part that I'm sharing with Patrick, and that's just the second half of semester. Okay. But going back to this, so you need to have some kind of capture software. All right. Do we have to be on the video? No, you don't. Okay, and I'll talk about that. Can it just be our voice? Absolutely. That's all I'm looking for is just your voice. You don't have to show your video like I am right now. How long should the demo video be? I'll talk about that right now. Okay, so let me go back to, these are good questions. So again, you've done your slide deck, and now you've recorded your video, and I think about this now, right? We're looking at like 4 slides. If you use about a minute or so per slide, you know, in that range, and if you keep it fairly a good length, I'm looking at maximum 5 minutes. Okay, it doesn't have to be more than 5 minutes, and that would be a long time to talk about stuff. To talk about yourself for 5 minutes, it sounds like a very short time, but actually minutes can last. You know, in 30 seconds, you can describe a lot of things about yourself. So really, I want you to write those things out. I want you to script them out when you write. I highly recommend you prepare. You could have something that you show on the slides about you. It doesn't have to be all words. I'm not telling you the format. I'm not giving you like a set format about, I only want 3 bullet points per slide or anything like that. You go ahead and go crazy. If you want to use animated GIFs, if that's something that you want to use and make it so that it's fun, you can make your demo video fun as long as it covers the sections that I've asked you to make. Title slide, about me, projects and interest, the future. Right? If you can talk about those things, that's all that matters to me. If you want to add some music that does not overpower, you know, your voice, it has to be music that I can listen to your voice over. So if your voice is more powerful than the music. Okay, music can be in the background, or you can bring the music up and bring it down if you want. It's up to you. And let me talk about that for a second. I don't want you guys to be, you know, video broadcasters or editors. I'm not asking for that at all. What it says down here under task 2 is you do not need to perform any post-processing or editing, but it would be nice. Okay? So what I mean by that is you can make a 5-minute video max about you, right? And leave it like that. Just record once and you're good to go. As long as it's good enough. You might want to take a couple of takes just to make it so it's better and better. But more or less, if you make one good take and it looks good, I'm okay. Right? It's just about you. Hey, I get to know you. You get to know me. And everything's fantastic. Okay. Task 3. Upload your video to YouTube or another streaming provider. I highly recommend YouTube. YouTube is very friendly for you guys to set things up. However, you need a few things. You need a Google account. You must have a Google account. And you need to have a YouTube channel. I know, guys, I'm timing out. If you give me another minute or so, and then I'll let you guys go. I just wanted to go through this so you know what I'm looking for next Tuesday. Right? You need to create a YouTube channel as well. So those 2 things you need to do. And you do not have to share your video publicly. You can make it private or unlisted as long as I'm able to look at it. Unlisted is easy. As you share the link with me, then I can look at it. And if you share the link with anybody you want, like in the future, other professors may ask you for a video demo. They might. Then this would be a good opportunity for you to share your stuff with them. And there's nothing wrong with this. And then the only thing I want you to submit at the end, I don't need your PowerPoint document. I just need your completed video with you voicing over and talking about your, you know, who you are and why you're here and the 4 things that I've asked you to put together. That's the only thing I want. A link to video on YouTube or some other streaming provider. Please do not give me a download link to Google Drive. I'm not going to download a 200 meg video. It's not going to happen. You won't get your 5%. You will not. I won't give it to you. Right? It's got to be a link on YouTube or Twitch or some other Vimeo, something else online. Okay? It's due next week on Tuesday, week 2, at midnight. and there's no extensions. So if you can't get it done, it's a 5% bonus. If you can't get this done, yeah, it's not much I can do for you, right? You have pretty much tomorrow and the whole weekend to get it done. It shouldn't take that long. If the whole video is 5 minutes, maybe it'll take you 20 minutes to record and create the slides and so on. How could you know we uploaded the file on YouTube? By link? Yeah, you're gonna give me the link. No, you're not gonna email it to me. You're gonna put, there's actually a assignment. So let me show you the assignment. So if you look at eCentennial for today, there is an assignment right here, right? And this assignment is the bonus assignment. All right, so it's 5% bonus, right? And if you actually go up on eCentennial and you look inside week 1, so if you go to content, and if you look at week one, you'll see inside there the 2 videos that we have for this week, these 2 videos, right? And then this personal demo video assignment, okay? So you would submit it in the assignment Dropbox. I'm looking for a link to your video. And this could mean that you might have to submit a text file, because sometimes you need to submit something. You can't just submit an empty thing. So you might have to submit a text file with your link to your video. And that's all I'm looking for, just a link to your video. You do not email. Please do not email me your links to your video. I'm not going to accept it through email at all, or text, or anything like that. It has to be through the assignment Dropbox. Okay. Any questions around this at all? Because I want to end now. We're kind of 3 minutes over, and I wanted to make sure that I have some time for people who have any questions when I stick around. All right, so that's really it in a nutshell. I'm looking for, I'm hoping that next week we'll see a lot of those come out. I want to get to know you because a lot of times I haven't had a chance to meet you yet. So this is an opportunity for us to meet each other and a chance to make 5 easy % on your final, for your final mark. So I think this is a great opportunity, and it'll kind of make the difference sometimes between, you know, maybe an assignment that you didn't quite hand in good enough, or maybe you couldn't complete a quiz or something like that. It'll make up that thing, and I think it serves a lot of purposes. One, it'll train you how to do the assignment videos better, right? So if you do this first one, it's like your dry run, you know, because I'm going to ask you to do the exact same thing every assignment. Go in, make a video, show me your stuff, upload it to YouTube, give me the link. I'm going to ask you to do that over and over again, okay? I want you to be familiar with YouTube, but it could be YouTube, it could be, so one of the questions is, why do you want us to upload videos on YouTube? Is that just because you want us to be familiar with YouTube? I'm just wondering. And the answer is, yes, I want you to get familiar with YouTube, but more or less it's my personal selfish reasons, which is I want you to upload it to YouTube so then I can literally just click a link and I can see your video. All right, it makes it easier for me to mark, and it's great for you guys to learn how to do it. Remember that anything we do here live, when we start sharing videos about ourselves, a personal demo video, I believe we're going to have to do more and more of this. If you want me to look into the future with you, here's a future that we can see. When you do your interview, there might be a high chance over the next 6 months that you're going to do an interview with anybody that you're hired from, like this, live, right? And I want you to think about how to put things together in a format that works on video. Okay, so that's one of the reasons that I want you to do it. Any other questions? Okay, that's it for me for this week. I'm looking forward to seeing you guys next week. Remember, next week what we're talking about is more about the GNOME environment, right? So make sure that your GNOME environment is ready to go, because I'm going to do more things with you next week around GNOME, and I'm also going to have quiz 1 probably on Tuesday. Just letting you know, quiz 1. Which is going to cover everything we've talked about today and yesterday. It could be questions around the history of Linux, and it could be questions around your installation, VMs, anything we've discussed in the videos is fair game, and it's worth 3% of your final grade for you to get this video, this quiz. So please don't take it lightly. Do it. Look at the videos, look at the material that we've talked about, set up your environment, and you'll be fine. Okay? I would respond to your emails, absolutely. So yeah, absolutely. If you wanna send me an email, I can totally respond to you. Where will be the quizzes? The quizzes will be live probably on, I'll make them available on eCentennial. So you'll have to do an online eCentennial quiz, almost like a little test. Okay? Yes. Okay, guys, thank you so much. I'm going to stop recording now, and I'm going to see you guys next week. I'm going to stick around for any questions you might have. Okay, anyone have a question? Stick around, and I'll try and answer them. Or if you have an installation issue, I can try and help you. So I'm going to stop recording now.